What's going on, guys? In this video we are going to take a look at introduction to practice of statistics. The definition, it says statistics is equal to the science of collecting, organizing, summarizing and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing measure of confidence in any conclusions. So this is usually used for calculating, like finding out future. We can take a decision based on this for the future things, okay, and also we can deal with the population with these things, statistics. Now let's look at the definitions. Populations is entire group of individuals to be studied. Individual is equal to a person or subject, person or object, that is a member of a population being studied. Sample, a subset of population that is being studied. Now we are going to do questions from this, so you will clearly understand what is population, the difference between population and sample. And also definitions of statistic is a numerical summary of a sample. Parameter is a numerical summary of a population. Now let's look at the first question. Determine whether the underlined value is a parameter or a statistic. Now here the average grade for the class of 25 students in elementary statistics was 83.2%. So here average grade for class of 25 students. So here they are taking the class as a whole thing. So it's treated as a population. So when it's a population, it's a parameter. Because here it says, if you look at the parameter of statistic, a numerical summary of a population is parameter. A numerical summary of a sample is statistic. Here it's a numerical summary of a population because the class is the first question. The class is treated as a whole thing, so it's a population. Now let's see the second one. Here, determine whether the underlined value of a value is a parameter or statistic. In a survey, 12,000 high school students, 74% of respondents indicated that they had cheated at least once an exam in the past year. So here we are only taking 74% from in a survey of 12,000 high school students. It's not the whole high school students, it's just 12,000. So we are picking a particular amount from the whole value. If it's a whole value, it's a population, but if we are picking a particular amount, it's a sample. And since we are dealing with a sample, this is a statistic. If you are dealing with the population, it's a parameter. Okay, so this is statistic. Now let's look at the third one. Determine whether the underlying value is a parameter or statistics. In a survey, it was found that 10% of married people have had external married affairs in the last year. So 10% of married people. So they are taking all the married people, and 10% haven't had an extramarital affairs. So we are taking the whole population. The population is married people, and 10% had extramarital affairs. So we are dealing with the population. Since we are dealing with population, it's a parameter. Now let's look at the fourth one. Determine whether the underlying value is a parameter or a statistic. Now in a particular elementary statistics class, only 50% of guys wash their hands after using bathroom. So they are taking the elementary statistics class as the whole thing. So it's a population because we are having a whole thing. So it's a population. So since we are dealing with population, it's a parameter. Now let's look at the process of statistics. First, identify the research objective, collect the data needed to answer the question posted, and describe the data, perform inference. Okay, now let's determine the research objective, the population being studied, and the sample. Okay, investigation of repetitive transcranial magnetic stimulation in depression adolescents. Excuse me. Here you can see the magnetic stimulation is the research objective. The research proposal aims to better understand the neurobiology of depression in adolescents. and how repetitive transcranial magnetic stimulation may therapeutically impact brain function and mood. This research will be the first study evaluating metabolic changes in the brain as a result of rTMS treatment in depressed adolescents using the magnetic resonance spectroscopy (MRS). So determine the objective. Objective is magnetic stimulation. Research objective is magnetic stimulation. The population being studied. Here adolescents were the population being studied. So that's adolescents. And the sample. Depressed adolescents is the picked up thing. So that's sample. Because a particular amount from the population picked up is the sample. So this is depressed adolescent is the sample. Now let's look at the next question. Determine the research objective, the population being studied, and the sample, the descriptive statistics. Beat bullying found that up to 44% of suicides among 10 to 14-year-olds may be bullying related. The charity said 26 out of 59 cases reported in the national media were linked to intimidating behavior. So here the research objective is beat bullying, and the population being studied is 10 to 14-year-olds. The sample is 26 out of 59 cases. So that's our sample, and that's the answer for this question. Now definition. Let's look at the definition. Descriptive statistics consists of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs. Inferential statistics is uses methods that take a result from a sample, extend it to the population, and measure the reliability of the result. Definitions. Variables, the characteristics of the individuals within the population, weight, age, etc. Qualitative or categorical variables allow the classification of individuals based on some attribute or characteristic. Quantitative variables provide numerical measurement of individuals. Math operations such as addition and subtraction can be performed and provided meaningful results. So here we are going to study about this one, like we are going to do more questions on this qualitative and quantitative. The easiest way to remember is quantitative. You can have numbers, like you can measure, and those kind of numbers is quantitative. Excuse me. Sometimes the number might not mean anything. In that way, in that situation only, the number will become a qualitative. Now let's look at some examples. First, classify the variables as qualitative or quantitative. Here, hair color, there's no number for the hair color, so this is a qualitative. Classify the variable as qualitative or quantitative. Number of pets, it's number of pets. It can be 1, 2, 3, something like that. So quantitative. Classify the variable as qualitative or quantitative. Social security number. Here we have social security number is a number, but not number doesn't mean anything. It doesn't count or it doesn't mean anything. Since that doesn't mean anything, it's a qualitative. Classify the variables as qualitative or quantitative. Assessed value of a car. Assessed value, the car price means something, like for example $3,000, $5,000, the difference means something, so it's a quantitative. Definitions. Discrete variables, a quantitative variable that has either a finite number of possibilities or a countable numbers of variables, no decimals. Continuous variables, a quantitative variable that has an infinite number of possible values that are countable, has decimals. This is a main thing we can differentiate quickly. Has decimals and no decimals. Discrete, no decimals. Continuous, has decimals. Now let's look at examples on that. Determine whether the quantitative variables is discrete or continuous. Amount of oil in a car at any given time. Car oil can be like, it's continuous because that is amount of it can have 2.5 liter, 2.6 liter, and it can have decimal values. Like if we have decimals, it's continuous. If we can have only 2 liter, 3 liter, 4 liter, then it's gonna be discrete, but liter can be 2.6, 2.7. So since it has decimals, it's a continuous. Determine whether the quantitative variables is discrete or continuous. Number of deer in a forest. We can have 1 deer, 2 deer, 3 deer, but we cannot have 1.5 deer, we cannot have decimal points. So this is a discrete. Determine whether the quantitative variables is discrete or continuous. Age of a student. Age of a student, like some of them, but age is really continuous, because you can have 3.5 age, 3.5 age, 3.6 age, like you can measure, like, but we don't treat like that. We say whether you are 20-year-old, 21-year-old. We don't say 20.5-year-old. So we treat this one as a discrete. So this is a discrete. Determine whether the quantitative variables in discrete or continuous. Temperature of the water in a swimming pool. Temperature can be 30 degree, 31 degree, but we can also say 30.5 degree, 30.6 degree. So we can have decimals. So since we can have decimals, it's continuous. Definitions. Individuals, a person or object that is a member of a population being studied. Variables, the characteristics of the individuals within the population. Data describes the characteristics of an individual. Identify the individuals, variables, and data corresponding to the variables. Determine whether each variable is qualitative, continuous, or discrete. Okay. Now names. Names, just a name, so it's a qualitative. Okay, qualitative. And hair color also qualitative. And age is quantitative. Since we can measure age, it's a quantitative. And if it's quantitative, it can be continuous or discrete. So age, as we studied before, age cannot have the decimal points. Like we do not treat as a we do not treat age as a decimal point. We don't put 30.5 age. We say whether it's 30-year-old or 31-year-old. We don't put 30.5. So since we don't have the decimal points, we treat this one as a discrete. So this is quantitative and discrete. But weight can have decimal points. Like here also you can see 130.5 weight. We can have that. And 20.5, 120.5. So since we can have decimal points, it is continuous. Okay. And quantitative and continuous. Now levels of measurements of a variable. Nominal level measurement. Name, label, and categorize. Okay, hair color. And ordinal level measurements. Properties of nominal, but you can arrange by rank or order. Car size. Interval level of measurements. Properties of ordinal, and the differences in the values of the variable have meaning. Year of birth, addition and subtraction are okay. Levels of measurement of a variable. Ratio level of measurement. Same properties of interval, and the ratios of the values of the variables have meaning. 0 in this measurement means absence of the quantity. Multiplication and division can be performed at this level. Now let's look at it. Determine the level of measurement of each variable. Color of a car. So here you can see nominal level measurement. Name, label, or categorize. We can categorize. Hair color we can categorize. Car color we can categorize. So it's a nominal. And here determine the level of measurement is C of each variable. Class in high school. Freshman, sophomore, junior, senior. It's ordinal, because if you look at ordinal is properties or nominal, but you can arrange by rank or order. Since we can arrange by rank or order, it's ordinal. Determine the level of measurement of each variable. Year of graduation. Now let's see interval level of measurement. Properties of ordinal, and the differences in the values of the variable have meaning. Years of birth, addition or subtraction are okay. So here you can see years of graduation. So this is interval. And here determine the level of measurement of each variable. Weight of students. That is ratio. Let's look at the definition of ratio. ratio. Ratio level of measurement. Same properties of interval and the ratios of the values of the variable have meaning. 0 in this measurement means absence of quality. Multiplication division can be okay. Here weight of student, it means something, so this is ratio. And that's all about this. I hope you guys find this video helpful, and if you are trying to learn more about statistics or treatment of experimental data, I have more videos on that. I hope you guys watch that too. Don't forget to subscribe. See you next time.